We got 13 people out of 75. That looks about right for as far as meetup is concerned. And so I guess we're just gonna get into this class. Again, I was just showing some people, this is our GitHub repository. So now to be clear for anybody out there, this is not a like a professional GitHub repository. I just, all the material that I create for these classes, I want this to be all accessible to you folks. And there's that whole question is how do you make stuff accessible? Do you create a WordPress site? Whatever. I just decided to use GitHub. So this is here. It exists. You can download out of it if you want to. We're going to work on how good it is later. But you can come here, all the classes we've done so far. You can just click on, you can just click on the thing for it. Oh, don't do that. You can click on the thing for it. You'll come in here. There's code examples. There's labs. You have the lab book. You have the notebooks. You have slides. All of this is available for you folks to do with as you want. And again, if you want to teach your own classes, take all this material and teach your own classes, you can do that. Just so you know, though, the workbook is actually just the slides. So it's it's a PDF file, 3 slides per page. I would highly recommend that you all download or print off these workbooks and keep them for the class so you can write down notes. Everybody, and I do mean everybody, thinks that they do not have to take notes. They will remember everything. And what I will tell you is everybody doesn't remember any damn thing. So if you're actually trying to learn, I'd highly recommend you print those off before class. And then we also have, this is the lab book. So this is the labs that we're going to be doing today. Basically, the idea is once we get done with the class, seminar class, you can tippy-tap type out these projects out so that you get a better understanding of how this stuff actually works, and you can modify the code and play with the code and all that kind of thing. This is the lab book at GitHub if you want to, again, print those out. So like today, go to online classes. What are we doing? REST APIs. And yeah, like I said, we have the labs PDF here, and we have the workbook PDF there. I would recommend you print those out before class. But again, you do you. There are no grades. You cannot fail because I literally don't have a system for failing. Let's see here. Silicon Dojo, if you're new, authorityless, gatekeeperless, free to end user, hands-on technology education that empowers students to do whatever the hell they think is important. I've been doing tech education now since 2009. I've been doing tech since 1996. And basically my whole question here is, hey, can we make education, tech education as available as water? What if there was a world where education simply existed? Wouldn't that be cool? Yeah, I'm trying to figure out how that works. So basically, that's the idea of Silicon Dojo. What if this simply was here? Whoever wanted to come to learn could come to learn, and I would try to teach them as best I could. Again, free to the end user. Right now isn't free. We don't have sponsors. We don't have advertisers, that type of thing. We do have a donor box link, donorbox.org/ETCG. If you want to throw a couple of dollars in per month, that would be so lovely. If everybody throws in $1 or $2 per month, that's a surprising amount of money to help keep this going. I will start talking about donor box more in the fall. So the past couple of months have been a bit of a disaster for me outside of the frame. So was doing stuff in July. I just have a stupid amount of crap to do in August. And so my hope is really to start pushing this forward basically in September and going forward. So we're going to be having 2 to 3 classes per week. We're going to start having a whole bunch of different things, and then we'll talk about donor box more. So yeah, let's see here. If you have a question and you need to raise your hand, I was worried that I'd have too many people raising their hands during class. That's not the case. But I do need you, if you're going to raise your hand, to actually I always get this confused. Raise your hand in Zoom because some people, like when I tell them to raise their hand, they do this, which is adorable, but useless at the same time. Don't do this. Do that. And you think, oh, he's just being an ass. No, I'm not just being an ass. That really does happen. Let's see here. Copyright, everything that I've created here. Basically, it's free for you folks to use. You can take all this, you can take it home, you can play with it. Again, you can create your own classes. You can create your own material that you charge for. There may be some things that have some branding some kind of, intellectual property. Please don't fuck with that. Again, my logo, don't fuck with my logo, but otherwise, all the other material is fine for you to use. Tippy tap or die. Again, a lot of people think that they're going to learn how to code. And they're like, I'm going to sit here and I'm going to learn to code. And then they just sit there. And then a year from now, they can't code worth a damn and they don't understand why. If you do not actually code, you're not going to learn to code. Again, I want to talk about those labs, the labs. So every class that we do, we're going to have at least 3 labs at the end. I will stay after the seminar for half an hour to an hour as you folks complete the labs. It's your job to sit with VS Code and actually type out that code to see if it works. Because in order to be a coder, you don't have to be smart. You do have to be precise. So remembering single quotation marks, remembering how to open things and close things, right? Just actually doing that, right? It becomes muscle memory. If you don't do that work, you're not going to learn how to code. So if you want to learn how to code, make sure to do the labs at the end. If not, again, there's no grades. You do you. Let's see here. Extra help, w3schools.com. Absolutely great. If you don't know about w3schools.com, go to w3schools.com and ChatGPT. Again, ChatGPT is not artificial intelligence, but it is really damn good for helping with coding projects. Let's see here. And finally, standardization. So we get those questions like, Eli, do I need to use VS Code? Again, no, you can use whatever the hell you want. If you want to use Notepad, God bless you. But when you are doing the labs at the end, if you run into a problem, we can do screen share. And here's the thing, if we do screen share and your screen looks like my screen, it's a lot easier to troubleshoot. If we do screen share and I see black and white because you're using Notepad, again, I'm an instructor. It's my job. I'll do my best, but it does make life a hell of a lot harder. So again, we focus on Python here, PyCharm. There are a lot of Python IDEs out there. I am not snarking on any of those IDEs. I'm sure they're fine. We use VS Code because literally everybody I know uses VS Code. And so this is just how we standardize. That's how it goes. And that's the spiel. That is that particular spiel. So let me close that. And we can get to the class. Is that already maximized? It's already maximized. Okay, so we're going to be dealing with Python. Python, again, it's the main language that we use. REST APIs, the requests module, and JSON. So one of the big things to be thinking about whenever you're going out there to figure out what programming language you're going to learn, because everybody wants to know, what programming language should I learn? One, it's not going to be one. It's probably going to be about 10, to be frank with you. But two, the next thing you have to think about is, what problem are you trying to solve? Right, that's a big thing. Right, so if you're trying to create front ends, you're going to be using JavaScript most likely. If you want to be building for what's called the Microsoft stack, Active Directory and all their kind of stuff, you would be using something like C#. Right? So Python, when we take a look at Python, and why is Silicon Dojo focusing on Python? It's because Python is kind of the super glue for the modern world of technology. What's really great about Python is you can use it to speak to damn near anything, pull on that information, do something cool, and then spit out a result, right? So Python can talk directly to your operating system. Python can talk to all kinds of databases out there. And one of the big things is that Python is there for communicating with services, or basically APIs, that can provide you services or information. So let's say you want your program to be able to send out SMS messages, right? So you got your smartphone. Anyways, you want to be able to send out SMS messages for people, alerts, two-factor authentication, that type of thing. Basically, you can use what's called an API for your code to be able to talk to Twilio, which is a service provider for SMS services, and basically be able to send out a message. So you say, I want to send this message to this telephone number. Here's all my credentials with Twilio. Let me ship all that off to Twilio, and Twilio takes the credentials, and then ships off to that phone number the message that you want sent, right? And that's one of the really cool things here is so basically, instead of having to reinvent the wheel, so when I started in technology, 1996, it was a whole different world. Again, when I started in IT, so I had my MCSE from 2000. And the thing was, back in 2000, any service that you wanted, you had to own. And when I say you had to own it, it means you literally had to go out there and you had to buy the physical damn hardware. You had to install the operating system. You had to install the server service they were going to put on there. You had to have all the configurations. You had to pay $500 a month for a T1 line, a 1.544 megabit per second connection line, and you had to own all of that. So if you had this amazing platform, and then the CPU fan failed on one of your servers, everything died. It was horrible. It was good for money. It was good for money. Kept me employed. It's just a disaster. Anyways, so we get to the modern world. Again, we get to the 2010-ish timeframe. We get to something called service-oriented architecture. What service-oriented architecture means is that basically you don't own the services that are required for your platform, whatever the hell it is that you're building. If you need email services for your platform, why build and buy a $20,000 email server? So Exchange servers back in the day were $20,000 plus CALs and all kinds of other stuff. But anyways, right? Why buy a $20,000 server when you can simply ping SendGrid? SendGrid is an email service. And you can just send out your emails that way and then pay like 1 penny per email, right? Basically, that's where we went to this idea where other people were basically going to be owning the services that we're going to use, and then our systems would then communicate with those services to pull in or push out whatever it is that we cared about, right? And so anyways, one of the ways that we do that with Python is using something called REST APIs. So there are a lot of different APIs. API means Application Programming Interface. Basically, this is where your code is able to talk to their systems. But basically, REST is one of the ways that you can do that, and that's what we're going to be talking about today. REST, the API, this is the connection that we're going to use from our script to their service. The requests module is the actual module that we're going to use in Python to be able to talk to those APIs. And then JSON is the data that we're going to get back, and we're going to learn how to parse and read that today. So what is an API? Again, it's an application programming interface. This is the portal, this is the door essentially, where your script is able to communicate with somebody else's systems, whether it's Twitter, whether it's Facebook, whether it's Twilio, whether it's SendGrid, whether it's OpenWeather, whether it's OpenAI. We're going to do a lot of stuff with OpenAI going into the future. Basically, it's a door. So when you think about this, again, when you're talking about the API, essentially, and this is something to think about, you got to think about the architecture. It always comes back to the architecture. You're going to notice my face. I always get smiley when I talk about architecture. I'm an old school systems guy. So when I get to talk about architecture, I get to be a happy boy. When I have to talk about Node, I just get sad and angry because I don't like Node. When I get to talk about systems, I get happy. Anyways, so basically what you have, right? So in the old days, again, you had your server and it would communicate with another server that you owned. So you had the hardware there, you had the OS there, you had the data store there, you had the software that would do all this stuff. That would have to be connected out on a T1 line, all of that kind of stuff. One of the nice things here, one of the nice things with the old school form of architecture is you actually knew what the hell was going on. See, there was a thing, I have a phrase I talk about a lot, distrust, verify, and stay suspicious. Again, I used to be in the military. As in, don't trust anybody ever for anything, right? Anyways, and the good thing in the old days is that you more or less knew what was going on. You knew your hardware, you knew your operating system, you knew your software, you knew your configurations, you knew your data store, you knew your fiber, or you knew your data lines, the whole 9 yards. But the problem is literally if the CPU fan fails, all of this craps to bed. Right? You get a call at 2 o'clock in the morning. Anyways, so that's why now, let's say we have like Twilio. We use a Twilio service. Or actually, let's talk about OpenAI. Because everybody likes OpenAI. If you want to make money right now, slap AI on it. Does it have to be artificial intelligence? No, just put AI on it. You'll make more money. So anyways, so now you have your script. So you have your script over here, and you have your server, and it's doing whatever the hell it's going to do, right? And so they have their infrastructure, their services. So again, when you start talking about infrastructure, or production scale infrastructure, there's something called things like clustering. So like when you have database servers, you can actually connect all these different physical servers together with what are called replication strategies, and they can send and move data around. So if one server fails, the rest of the cluster stays up and running. There's a lot of cool stuff like that. There's virtualization, all kinds of stuff going on. So anyway, so OpenAI, they create their system. So they create a SAN in here. Some of the SAN is called a storage area network. So this is like a cluster for all their storage. In that, they create some kind of database configuration going on. They have their reverse caching servers. They've got all kinds of stuff going on, right? But this is all behind a wall. This is behind a wall. You do not get to touch their SAN. What is the configuration they're saying? Who the hell knows? You don't get to know what that is. How many servers do they have in their cluster? Who the hell knows? You don't get to know what that is. What are the CPUs of the reverse caching servers? Who the hell knows? You don't get to know that. What they do is they open up a door. They open up a little door right here, and that is called your API. And basically, through this little teeny tiny door, you're able to put a request in, and then get the data out that you're asking for, right? So again, if you're taking a look at OpenAI, they've got amazing, massive, insane stuff going on in their infrastructure. All you get to do is you get to ask it a question, and it will return a response, most likely in JSON. And this is all you're able to interact with. So the important thing to understand with this, when we start talking about this API, is that how this API works is completely and utterly up to the service provider. So when you talk about the API, one of the big things to understand is it's a relatively standardized thing at this point in time, but it's completely up to whoever is running their systems. So PHP used to be an incredibly popular programming language. Back before 2010. And one of the reasons that PHP died in popularity is when all of these APIs started to become available. The APIs were all written so that people could communicate with them using Python and not PHP. And so now people wanted all these fancy toys. They could not access those fancy toys using PHP. You had to use Python. And so now a lot of people use Python, right? The new programming languages, right? So anyways, so when you communicate with the API, they are going to define how you are able to communicate with their particular systems. And that's one of the things to consider. So again, we're talking about OpenAI. OpenAI has a way for communicating with their APIs. Azure, Microsoft Azure, cognitive services, really cool. There's a specific way for communicating with their APIs. But basically, that's what we're talking about with the API. And again, for anybody at home that's been paying attention, notice you have no idea. Let me repeat this for the 1,000th damn time. You have no idea what's going on this side of the API. You send stuff in. You don't know what happens over here. Just going to point that out again and again and again. Anyways, I talk about service-oriented architecture. Why these APIs are important is basically when you write your code, one of the big problems that comes up is what happens if you don't like the server you bought? All right, so back in the old days, I'd have my server and I had my script on it, and I would communicate with the other server that I bought and whatever services were on there. Now, it might be a surprise, but every once in a while, you'd buy a server that was supposed to provide services that would suck, like a Microsoft Exchange server back in the day, or GroupWise. Anybody have experience with GroupWise? Oh, that was a disaster. Lotus? Anyways, So one of the issues is, back in the old days, you would have your script and you would have your server, and it would communicate with a very specific proprietary server in order to provide whatever services. And then most of the time it sucked. Again, there was something called vaporware back in the day. Vaporware sucked. Anyway, so the problem is crap, what happens if you don't want to use this piece of crap server anymore? And the issue was, again, back when you owned your own infrastructure, you might be able to buy another $20,000 server with another $10,000 of software on there and pay somebody like me another $20,000 in order to configure it and move it over there for that kind of stuff. So that's where they came up with the idea of service-oriented architecture, with the idea of what if they're just services? Services. It's not servers, it's not operating systems, it's not that, it's just a service, right? So now you have your little server here with your script running, right? Your script is running where your script is running. And let's say you decide you want to use Twilio for your SMS services, right? So SMS messaging services, you decide that you want to use Twilio. Now, Twilio is going to cost you a little bit of money, right? Twilio is like the luxury brand of SMS messaging services. So it's going to cost you a bit of money, but it is incredibly reliable. You shouldn't run into a lot of problems. They have adequate security at least. So you decide you're going to use Twilio to send out your SMS messages. Well, here's the thing. What happens if your company absolutely explodes? Right? You just get so much traffic coming to your site, and because of that, you're sending out just a metric crap ton of SMS messages, and then all of a sudden, your chief financial officer, right, the person actually taking a look at the books, goes, "Oh my God, do you know what 1/10 of a penny times a million is? A lot." Right? Because that's what you're thinking. When you start using Twilio, it's like, okay, every SMS message I'm going to send out is going to cost 1/10 of a penny. Right? That's nothing. Make it rain pennies. Who the hell cares? Well, here's the thing. You become the next Instagram or whatever the hell else. And, 1/10 of a penny times lots and lots and lots and lots and lots of zeros ends up being a lot of money. And so one of the things your CFO may come to you and say, look, Twilio is just too damn expensive. We need to go from 1/10 of a penny to 1/100th of a penny. We can accept some loss in SMS messages. Maybe 1 out of 1,000 SMS messages just gets tagged, doesn't go anywhere, something like that. That's fine if we can get this price down. And so let's say there's not Twilio. So there's a service out there called Not Twilio, and they sell SMS messaging for 0.001 cents, for 1/100th of a cent, I suppose. And so the thing with the service-oriented architecture is all you have to do is in your script, you change a few lines of your code, and all of a sudden, everybody is now going to Not Twilio, and you're no longer using Twilio, and the SMS messages are going out. Every once in a while they get tanked, but you're only getting charged for 1/100th of a cent per one that goes out. And so this is what we're talking about with service-oriented architecture. In the old days, if I wanted to change the type of server or this type of service that I was using, I'd have to buy a server, do configurations, and do all that kind of stuff. Very expensive. I know, because I used to bill for it. Very expensive, very time-consuming, god-awful. Nowadays, with service-oriented architecture, you literally create an account, swipe your credit card, change a couple lines of code, and now you're just using somebody else's service. And that's why service-oriented architecture is powerful. But again, we talk about cybersecurity in the modern world. You hear about these disasters, cybersecurity. You're like, why is security so bad? Well, because you can either own the boxes that you're using and know everything that's on those boxes and configurations and all that kind of stuff, and pay, let's say, $50K per box, essentially. Or you can pay 1/100th of a penny per request, but you have no idea what's going on with that on that side of the wall, and who do you think's going to win in the modern world of business? So that's, again, what we're talking about with service-oriented architecture. So what is a REST API? So you're gonna hear a lot of acronyms and things in the tech world. We just have to have words. Like one of the big problems with new people is they just focus on words way too much. We just need words to be shove a word in there. Oh, that looks fine. And then we just keep using that word, right? So you hear REST API. It's like, whoa, whoa. And no, don't get me wrong. For the actual computer science people out there, they're going to get pissed when I talk about this. For actual computer science people back there, there's a lot that goes into REST API. So again, when we're doing this whole communication scheme, one of the things that they have to come up with is standardization, right? Basically, um, okay, if we're going to create this and we're going to have a gazillion different types of clients connecting to this, how are we going to create a standard way for all these people to communicate? So before REST, I don't know if it was before REST, during REST, I've never dealt with it before. There's something called SOAP. SOAP was an API strategy. But anyways, basically with REST, what they did was they came up with the system of standards for having your scripts be able to communicate with their APIs, be able to get data back, and have it in a format that is easy for your systems to parse. Again, that's going to be one of the big things to be thinking about whenever you're designing your systems is your scripts can automatically read data that's coming in and then do something with it. Here's the thing, the better that data is formatted, the more standardized that data is formatted, the easier it is going to be for your script to parse. Again, I've talked about this before. I had a buddy of mine who was doing an interesting startup, basically getting all the health records or the sanitation reports or whatever for all the restaurants in the United States. And he thought Americans cared. It's like, it was so adorable. Oh, you think Americans give a damn whether this restaurant got a C rating or not from the health department? No, we don't. Anyways, but one of his big problems was every single county in the United States had their own way of formatting the data. So him coming up with a startup idea, hey, we'll parse the standardization data for restaurants. We'll put that into our platform, and then people will be able to determine how healthy the restaurant is, right? That seems pretty simple until you get to, I don't know, however many counties, like 5,000, 10,000 counties in the United States. It's only a ridiculous number. And every one of them has their own way for formatting the data. And that becomes an absolute nightmare. And so that's why we talk about standardization, since it's important. And so JSON is the format of the data we're going to be getting back from REST APIs. And so that's going to be one of the things is basically when you're thinking about having your computer programs be able to read stuff, how standardized is the data stream going to be when it comes in? So anyways, with REST, basically it stands for representational state transfer API. And I know that because I Googled it today because I knew somebody here would ask. I don't care. It's called a REST API. When you start dealing with APIs, any APIs, but with REST APIs, one of the things you might have to deal with is something called an API key. So I'm going to show you how to do these API requests in a little bit. What the API key is basically it's a security token. Think about it this way, basically for your account. So when you make the request, one of the things that you're going to add to that request is something called the API key. If the API needs the key, and basically this is going to associate your request with your account. So this can either be used just to track how many times you're making requests. So even free services many times use API keys just because they don't want you to hammer the hell out of their service. So they might be like, here's a free account and you get to do 1,000 requests per month. And so what that API key does it just simply ticks off how many times you've made a request. Or with a lot of the APIs, you actually do get charged money. Again, you get charged that 0.001 cent for every time you make a request. So one of the things to be thinking about with the API keys is be careful with them. One, if you get them wrong, your request isn't going to work. If you don't have one, your request is not going to work. But the other thing too is do be careful that especially if you're getting billed for your API key, that API key doesn't get out into the real world. Right? Because it's just the key. It's just number, right? And so if somebody else gets it, unless that API allows you to lock things down, which they usually don't, anybody else in the world can use your API key, and they can charge your account 0.001 cents every single time their script is able to loop through, and everything can go to hell pretty quickly. Why this becomes important is, again, I talked about before with GitHub. Where's GitHub, right? GitHub. You'll notice here things like code examples. And again, if we take a look at this particular code example, again, this is the API request that we're going to make. There is no API key here because I didn't want to get into that horse crap today. But something to think about is if you write all of your fancy code and you want to get hired or you want to get promoted, so you upload, you keep your GitHub repository updated like you should as a good little computer geek, and you put your API key in here. There are bots and such out there that will literally search for API keys on GitHub, grab those API keys, and then you become a very, very sad geek. So with the API keys, be very careful. Best case scenario, somebody takes your API key, they just run up however many times they can use it until they hit the max on the platform. That's just annoying, not really a big deal. Worst case scenario is that you actually swiped a credit card for that API key. You did not put a limit on how much you're willing to spend, and you're going to get a $5,000 bill at the end of the month. That is a real thing that can happen. Again, when we do the classes on OpenAI, you'll notice sometimes I'll have the key up here, which is a security problem. And one of the reasons I'll have this key up there is because I limit the amount that I can spend per month to $1. If somebody compromises my API key on OpenAI, I might lose $1. But that's something to be concerned about when you're dealing with the API keys. Beyond the API keys, again, with APIs, you might hit limits. So these might be hard limits, especially for free accounts. You can make 1,000 requests per month. You can make 50 requests per month, whatever. You get the point there. The thing that might really screw you up, though, is rate limiting. So what rate limiting is basically how quickly you're able to hammer their system. And this will come up, especially when you do loops, right? So we talked about loops in previous classes, or lists in previous classes, and looping through a list. So let's say you create a list, and you create a list of, oh, I don't know, 20 different pieces of information. And you're going to ask an API about each of those 20 pieces of information. So you do a for loop, right? So for X in list, make this API call. Remember, when you do a for loop, when you do any loop, unless you put a delay in there, it will literally go as fast as the CPU is able to go, which doesn't seem like a bad idea. The issue is if you have rate limiting on some of these APIs, some of these APIs will say, and again, it may seem like a lot, like, oh, like you can do 3 requests per second. That doesn't seem like a problem, right? Well, the thing is, if your system is literally going as fast as it possibly can, it may be able to send 5 or 10 requests per second. And so although it seems like 3 requests per second is a lot, your script might start crashing, essentially getting into real problems, because it'll do the first request fine, second request fine, third request fine. You hit that rate limit, and then all of a sudden every request after that might fail. Again, 2 or 3 requests per second is actually very generous, especially for free services. One of the things that you might run into is literally 6 requests per minute or 5 requests per minute or something like that. And so one of the things you might have to add into your script is simply a delay. You know, for X in list, make the request, delay 10 seconds. Make the request, delay 10 seconds. Make the request, delay 10 seconds. And that's one of the things that you're going to have to look at with whatever particular API that you're running into, but that can be an absolute and utter disaster. I ran into that. So when I was doing the physical in-person classes, OpenAI initially, whatever it was, a year and a half ago when their API came out, they had a free, so they gave you like $15 in API services that you could use. And so we were doing a class on it. So we're doing an OpenAI API class. And I wrote all this code, and basically all the people were going to tippy-tap type and do it. And we had 10 people, so we're going to have 10 people in the class. And I was going along, and yeah, ran into a random problem, right? All the code was working. It 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 was working. And then I went into this loop. There's this loop I wanted to have done. And as soon as doing the loop, it started breaking. And again, it was like, oh, what the hell's wrong? Is there something? Is there a problem with the loop? Is there a problem with the API key? What the hell's going on? And the issue is for the free service of OpenAI, they had a rate limit. So not only did they have a $15 limit that they were giving you, but they also had a rate limit per minute. So simply by me doing that loop, I was hitting the rate limit. And why I'm happy I learned about it when I was doing testing is imagine if 10 people at the exact same time had been using my single API key. They all hit enter for that script to run, and then everything goes down. So again, rate limiting can be an important thing. Caching, whether to cache or not to cache. So basically when we talk about caching is you make a request up to the API. So let's say this is OpenAI's. So you're expecting to get a response back. What a caching system does is basically you put a little server or system in the middle of when the response comes back, and it stores the response. Right? So basically, again, if you go to OpenAI and you say, I don't know, when did the Civil War end? What day did the Civil War end? And you make that request, you're going to get an answer back. If you have a caching system, basically what you can do is you can cache, you can store what the request was, you can store what the response was. And then in the future, when somebody asks the same question, instead of that going all the way to the API, that can simply go to your cache and get returned directly to your user. Basically, that's what a caching system does. Caching is awesome. Use more of it. Here's one of the interesting things with these APIs. Some of the APIs forbid you to cache the data. Right, so especially when you're dealing with like IP address information, telephone information, IP address information, that type of thing, you make the request, and literally, if you read the terms of service, you're not allowed to cache that information. If they find out you're caching it, I don't know, they'll smack you on the hand or something. That's something to keep in mind. So some APIs say, no, don't do it. Interestingly enough, when I was doing this class, some APIs actually damn near demand that you do it. I ran into an anime API. Again, just doing some random research. Hey, there are anime REST APIs. I don't know. If you want to know what the hell Dragon Ball Z is about, I guess you can create a script and it'll give you a response. Anyways, the interesting thing with that is it demanded you use caching. It basically said that that any server or whatever that put too much load on their server, it would just get IP address blocked. And so they said, basically they said every time you make a request, make sure to cache, again, the request and the response every time so that you put as little load on their server as possible. So that was an interesting one. So again, that's the whole thing. Again, we talk about these APIs and how they work and how they interact. Again, it's basically what the people design it for. Essentially, when you start looking at the REST API, what we're going to be dealing with is essentially the response. What it's going to look like is a web page. Imagine a web page if it was actually simply designed for computers. Right? So when you go to a web page, you want pictures and sounds and banner ads or whatever. Right? Computers don't want that. Computers don't want that. Computers just want text. And so basically, if you go to the API pages, I'll show it to you, you'll get a response back. And the data will either be in XML, something called extensible markup language. It looks a lot like HTML, only it's customizable. You have tags. So XML is used in RSS feeds. XML is used in podcast feeds, that kind of thing. So you can have data that's formatted for XML. So again, your computer knows how to parse it easily. JSON is what we're going to be dealing with today. These are key value pairs I'll show you, or basically HTML or text. We take a look at that. Oh, this is basically what the quote unquote web page, or what the API response looks like, right? So with this, I'm using a REST API called ip-api.com, asking for a JSON response, and I'm asking about a particular IP address. So I want to know information about a particular IP address. What's going to get sent back to my script is this, right? And it's going to say status, success. So it was able to get a result. The country this IP address is the United States. The country code is US. Region is California. Region name is California. City is San Francisco. Zip code is this. Latitude is this. Longitude is that. Time zone is that. The ISP for that is this. So on and so forth. But you can actually take a look at this. So when you're using, one of the cool things about REST APIs is, especially if you're doing troubleshooting, you can't really figure out what the hell you screwed up. Most of the time, you can pull up something like this, and you can actually just take a look at this within your web browser. So this is simply Safari. This is simply Safari. This is my address bar. You can actually pull up the information here and take a look at what that response looks like. And so that's what I'm saying is, with these REST APIs, when I say it's like web pages for computers, here we go, right? We get this web page that's very easy for a computer to parse so you can find information. Let's see here. Yeah, if we go to examples, different ones, we're going to be using these today. So IPify API. So this is very useful. This is very interesting. So this is an API that allows you to get your external IP address, right? So your external IP address, if you're a gamer or whatever, you might have used this for port forwarding in the past, right? The external is your modem connected to the internet, that internet-facing IP address, right? What is that? That's what IPify allows you to get. And basically, they give you a whole bunch of information here. It's completely open source. You can use it without limits, blase, blase, blase. And then they give you the API usage. So basically, how do you actually use it? This kind of thing. And this will just give you that external IP address that you might want to use for any number of reasons. We have this over here. This is IP Geolocation API. So one thing some people don't realize is that there's a database, I don't know, a lot of databases out there that actually contain a crap ton of information about your IP address. So your computer connected to the internet, you have that external IP address, right? Basically, that IP address is owned or is leased by ISPs. Those ISPs put information into a database about where that IP address is. Who is the ISP for that IP address? What is the country that IP address is in? What is the state? What is the city? What is the approximate latitude, longitude? All of that kind of information that might be useful for you with whatever kind of script that you're doing. So IP-API, basically, if you can take a look here, you can see, wait a minute. Is that my IP address? No, don't see that. Tunnel Bear, what are you doing? Damn you, Tunnel Bear. Never trust a bear. That's one thing I've learned in Asheville. Don't trust a bear. Anyways, don't look. Don't look. Let me refresh. Come on. No. There we go. Atlanta, Georgia. I'm in Atlanta, Georgia. Anyways, so this is all the information you get back. This is actually kind of sort of what a JSON response looks like. So it says this is what your external IP address is. It's in North America. It's the United States. Country code is US. Region, Atlanta. Zip code, latitude, longitude, time zone, currency. all of this kind of information. So this is one of the things you can get out of a REST API. REST countries, we're going to be playing with this today as far as the labs are concerned. Again, there's all kinds of REST APIs out there. Again, there's anime APIs, all kinds of stuff. This one is actually kind of interesting. It's a free API for getting information about countries. Do you want to know the capitals of countries? Do you want to know where languages are spoken? That kind of thing. The countries, REST countries API, we'll give that to you. And then if you go to GitHub, I think there's a link somewhere. Try public APIs for free, and you can come here on this particular page, and there's just a metric ton of different APIs out there. Cat facts. I mean, again, if you're looking, you're thinking, you know, if dog dating apps are going to be the next Facebook, then maybe cat dating apps will be the next TikTok. And so there's actually a REST API for cat facts. So you can have your script learn a crap ton about cats. Again, and that's the interesting thing when you start playing with this. There's a lot of cool APIs out there, I gotta say. So anyways, those are different APIs. Let's see here. Okay, so what is JSON? Again, JSON is basically the format of the data that you're going to be getting back. Again, if we take a look at that web page that I was showing you earlier, not that. This is basically what JSON looks like. Again, if you pull it up on a web page, you have key value pairs. So in the Python world, this looks a lot like a dictionary. Basically, it's going to look a lot like a nested dictionaries and lists within a list. We'll get to that in a bit. But anyways, we have what are called key value pairs. So key status, value success. Key country, value United States. Key region, value California, so on and so forth. And so that's how you're able to call it, right? You make a request, you get the response. And basically how you're able to read that response is you're going to say response region, and then it'll give you CA. Response ISP, and it'll give you fastly. So it's a standardized way to send data on the internet. So again, that's going to be one of the big things, especially when you start building platform systems, is finding out, you know, whatever the standards are, and then basically sticking with it. They have the name value pairs, like I showed you before. And yeah, so when you talk about JSON, it's JavaScript object notation, which again, I know because I Googled it this morning. No one cares. It's just called JSON. Let's see here. Okay, the request module. So this is going to be the big thing in Python. Right, so again, as I showed you here, I can just pull this up by going to this URL. This is called a URL. The issue is in Python, how do you get your Python script to go to a URL? So you're going to use what is called the requests module. So the request module has a function called get, and get allows you to basically pull in information from websites. This is not installed by default. So there are a lot of modules that are installed by default within Python. Requests, for whatever reason, isn't. So in order to install the request module for your environment, you do Python 3, or if you're in Windows, Python space -m pip install requests. So we're going to use this way for installing modules going into the future. So if you know anything about Python, you can use pip or pip3 install requests. Why you use this longer version of the command is this will make sure that it gets installed within the environment you're currently using. One of the problems you get to with Python is you can have different environments and different interpreters and different versions. It can become a disaster. So although pip install module normally works, or pip3 install module normally works, sometimes it'll do something wacky. So if you do Python 3 or Python -m pip install requests, that will make sure that it actually installs that module into your environment that you're using and it doesn't float off somewhere else. Basically, you can use the function get. So the get is the function out of requests. And basically here is where you put in whatever the URL it is that you're going to be using. So you can put in cnn.com. So again, this is an interesting thing. When we talk about web scraping, we'll have a class on web scraping. You can just put in just a normal website, pull all that into your script if you really want to. But with us, we're going to be actually using the URLs for these APIs. As you pull data in from the web page, and it comes in as a variable value. So you put variable equals get blah, and then when that gets pulled in using the request module, that data will be assigned as the value of the variable. We go to get.py to show you how this works. So this is pretty simple here. So again, request module is already installed on the system. You can do, we haven't gotten to this yet. Again, one thing for me teaching these classes, it gets kind of weird. Like, what order do you teach stuff in? Anyways, we haven't gotten to pip yet. So you're gonna have to go with me on this. But if you're trying to figure out whether the request module is already installed within your environment, you can do pip list. So this is the package installer program, I think it is, list. Basically, it'll tell you all of the modules that are installed. Oops, pip3. There you go, pip3. Use pip3. There's this whole thing with the versions. Oh, Python is a pain in the ass. Anyways, there was Python 2 that you should never use anymore. And then there's Python 3. So anyways, if you're just using pip, you probably want to use pip3 and then the command, because that'll be for Python 3. I swear I know what I'm talking about. Anyways, this will show me all of the packages that are installed in this particular environment. Got all that different stuff. We have Olama AI package, very cool. And then we have requests. Request is what I care about. If request does not come up here for you, that is where you would type. Python 3 -m pip install request. So you do that. Man, it's already done for me. But anyways, that is what you would do to make sure request is actually installed within your environment. So once it's installed, from the module request, we're going to import the function get. Very simple. Response equals get, so that get function, and then whatever it is that we're trying to grab. Right now, we don't know a lot about REST APIs, so I'm not going to try to grab a REST API. So I'm just simply doing arstechnica.com. Again, with get, this is one of the ways you start doing web scraping, some cool stuff. Anyways, we then use a method to turn the value that's coming back into text. I'll show you this in a second, but we actually want it as text, and then we're going to print out what the response is. So we're going to grab everything from the home page of arstechnica.com, and we're going to print it out. And if you understand what HTML and CSS looks like, you will realize the ugliness that we are going to get. So this is the ugliness that we receive. If you have no idea what the hell any of this means, that's absolutely fine. I just want you to show you this to see how this works, right? Your California privacy rights. Do not sell my information. The material on this site may not be reproduced, distributed, transmitted, cached, or otherwise used except with the prior written permission of Condé Nast. Sure, if you believe that, good for you. Anyways, so this is all the HTML, the CSS, the JavaScript, everything that is getting pulled in using that get function. And again, doesn't mean a lot to you. I just want to show you can pull all of this in. We have Jock asking a question. Asked to unmute. Jock, how can I help you?
Good morning. You might have covered this before. I'm sorry, I was running late. Um, so basically, I'm trying to figure out, is this how most of the artificial intelligence companies are pulling data from these websites? Also, how like they have to create an API, the website itself has to create an API for people to pull the information out of in the first place, correct?
Well, no. So the websites, that's one of the things, and we're actually gonna have a class on this. So we're gonna do an open AI class next week, and we're gonna do an AI web scraping class in a couple weeks. So all of this information is basically just there. Like this is all available on the internet. And so what they're doing is they're just instead of just showing it on the screen like this, they're saving it. They're cleaning up the data just so you don't get all this garbage and then they're feeding it to their AI system. So that's how this is able to work. So if we go like just to oh, where is my thing? Right. So this is this. So if we go to arstechnica.com, right? Let me click on something, right? So this is this article, right? So if we do go page source, we can actually look at the source. And so this is kind of that crap that I was just showing you. But through this, if you know how to do web scraping, what you're able to do is you're able to pull out just the story itself. And so there's something called Beautiful Soup. We'll deal with that in a couple of weeks. That can actually go in, and what it can do is it can grab just the text that we care about on this web page, pull that into your script, and then you can put it into your data store and do whatever you want. So that's how these AI companies are doing it, and that's why there's this thing called robots.txt file. We won't get into it a lot today because it's its own subject. Anyways, this robots.txt file is supposed to tell companies what they can or cannot do, what they should or should not scrape. But what you'll notice here is I don't have to pay attention to it. It's kind of like around here in Asheville, we have little signs that tell you dogs should not pee on the yard. And many times Roxy is peeing on the sign itself. It's like, well, you told me not to, but it's a dog. What are you gonna do? And so yeah, that's kind of like with these robots. Fine, like they're supposed to be warning signs, but your dog can piss on it if it wants to. So, anyways, that's how the AI companies are able to scrape all this information. It's really just there. It's incredibly easy to do. Um, as far as APIs for these companies like Ars Technica, you don't need an API. Again, I can just come to this site and I can scrape the ever-loving hell out of it. I can scrape every page off of this site, and there's not a hell of a lot they can do about it. So they don't have to do the API. So no API here. If you're dealing with OpenAI will create their own API, so then you can get access to their data. So OpenAI has an API. Ars Technica is getting peed on, essentially. That makes sense? I guess that makes
Unfortunately, yes.
sense. Unfortunately, yes.
So I got a follow-up question for that. So in today's day, because of that, do we necessarily still need to create APIs in a sense? I guess for like particular points of data that we are collecting on our website or whatever, so that people can access to the users. Say like hospital systems don't have APIs pretty much, or do they? Or like IBM and like Microsoft, they have APIs because you want them to use their software. So, what circumstances would you say API is needed as opposed to not? Like banking systems don't have APIs. Kind of see what I'm saying? The question.
Yeah, well, a lot of them do. So basically, the API is going to be used whenever one computer has to talk to another computer. Because a computer doesn't want to look at this crap. Like I can scrape it, but right. So basically, like the API. So let's say you could have a history website for humans, and that'll have pretty pictures and formatting and all that crap. But let's say you wanted to create a history API where it just had very basic information. This is when George Washington was born. This is when George Washington died. This is who George Washington was married to, right? At scale. That's where you create an API. So anytime you're going to have one computer communicate with another computer, That nowadays is generally going to be through an API system. So yeah, bank systems may be using APIs. They'll be using more secure APIs. Yeah, but it's going to be whenever computers are communicating with each other that you need the APIs.
Got it.
Cool. All right. Okay, let's
Uh,
see.
I don't
Oh,
know if this is something that you can answer, Eli, but I know some websites have a terms of service that prevent uh web scraping and other things like that. And I'm just wondering if we would get in some type of trouble by trying to access some of those websites.
yeah, well, maybe or maybe not. What is it? Yeah, with a lot of this stuff, again, I'm going to show you everything academically, and so I'm safe. I am teaching you. And I will try to explain as much legal stuff as I can. One of the issues that you get into, especially with things with like terms of service and all this kind of stuff online right now, is that this really in real time is being decided by the courts. What's really interesting, you go to the Copyright Office. So again, having been a YouTuber since 2009, a big thing that comes up is this whole question of fair use. And you get so many YouTubers and they just blovate for freaking hours about why they're allowed to do fair use or whatever else. What's interesting is if you actually go to the Copyright Office and you actually care about the laws, the Copyright Office itself literally says, here's some rules of the road for fair use, but nothing is decided until you go to court. The judge is the final arbiter. So that's the Copyright Office basically telling you that. And so that's the issue you get into with a lot of this stuff. What is legal? What is illegal? What is illegal to the point that you'll actually get sued over? Because again, remember, a lawyer is going to cost, my last time I hired a lawyer was $450 an hour. That wasn't even a great lawyer, right? So is it worth them to spend $30,000 to try to go after you? That's its own, right? So if you want to protect this, again, with this kind of thing, and we'll go on to the next bit. If you want to protect this, the best way to actually protect this is through a wall. So basically a login wall. It doesn't even have to be a paywall, like a login wall. So like this, I can just go to Ars Technica now, and I can just have my script scrape the hell out of this. If I wanted to protect Ars Technica's material, what I would do is I would create a login wall where the only way to get to these articles was to log in, and then that forces people to actually sign a terms of service, right? You come here, you haven't actually agreed to anything, which is an interesting concept. That forces you to agree to a terms of service. And then once you're within that system, they can then do more measures for trying to prevent you to do stuff. But yeah, legal stuff. Legal stuff is an interesting question. So yeah, there you go. Okay. So we did that. Okay. So reading the REST response. All right. So basically, we're going to make a REST request. We're going to use the request module. We're going to use the get function. We're going to make a request. When we get the response back, we're going to get a number of different responses that we can use. The status code response. So basically, when we make this request, we can actually get back whether or not the request went through. So a 200 status code means you actually got a response back. A 400 status code means that the response failed. So you can use this in if-else statements to say if status code equals 200 as in good, then do this. If it's something else, or if it's 400, then do something else, right? So if you're trying to do these API calls, you may want to do something like that. Headers. So basically, the headers is some of the additional information from the server that you get back when you make the request. You can take a look at the headers that may or may not actually matter to you. There's the text method. And so what the text method does is when you get the response back from the REST API, it will turn that value just into text, just into a text, right? So you may want that for certain reasons. But do remember that text is not a JSON. We've talked about data types before. Even if you have text and it looks like JSON, if you haven't actually turned it into JSON, you can't interact with it like it's JSON. So there's the .json method, and what that'll do is that will bring the value in, and then you can actually interact with the variable value as if it's actually JSON. Let's see here. We go to the ipify.com example here. Close this out. And this is the ipify. So ipify, basically this will give you your external IP address. So hopefully I'm still on my damn VPN. Yep, still on my VPN. All right, so it'll give you the external IP address. So from request, import get, the get function, result equals get HTTPS, and basically this is the site that you go to for this REST API. So api.ipify.org, that's where you go to. Now, let me just do this. Okay, so if all I do is I print the result, so, I showed you all that stuff from Ars Technica before, but the important thing to understand is if I do this now, all I'm going to get back is response 200. So when I do this, basically, I just get this response value back. I don't actually get the text because I'm not actually asking for the text. One of the things I can do is I can simply ask for the status code. So from this result, print result.status code. It's either 200, 400, whatever else. And so if I print this out, we can now see this was the original response. Response is 200. But if I just want the value itself, again, easier to parse for if-else statements, that type of thing, it will just give me the 200 right there. If I did ipify 8, I don't know, and try to run it again, well, then it just fails out. Never mind. We won't deal with that right now. Ignore that. If we want the headers, I don't know why you'd want the headers, but if you want the headers, again, we do .headers. And so we can see the response was 200, the date, this was the date it went through, the content type is plain text. Let's see here, the server is Cloudflare, so maybe you care about the server that the information is coming from. You get some information here. This is one of those things, higher level. If you need to know about this, you need to know about it. If not, don't worry about it. But those are some of the things you can take a look at. Then past that, if we do this, this is how we actually get the text, right? So result underscore text get API blah blah dot text, and then we're going to print out what that value is. And so that is how we're just going to get. That's how we're going to get the IP address. So when you go to ipify here, basically, if you don't ask it for JSON, so for this particular API, if you don't ask it for JSON, it will just give you a text value back. So sometimes you might actually not need to use JSON with these REST APIs, because if you're only asking for like one piece of information, I don't need a lot of information, I just need one thing. I just need my IP address. I just need whatever. They may have a way to give you that just in text, and then you don't have to worry about the JSON. That's what we have going on here. But if we go down, we can take a look at this, and basically, so this is result underscore JSON is going to get basically API ipify.org format equals JSON. So this is what you get from their web page, and then we turn that into JSON, and then we're going to print that out. When we print that out, so this is the text that we got before, and this is what text looks like. This is what the JSON response looks like. So you open up with a squiggly bracket, you have the key, so the key is IP, and the value is 45.76, right? That's the IP address, that's a key value pair. So basically how you access that data, if all I want, so it's like, okay, I'm getting that key value pair, but I don't want a key value pair, I just want the value, I just want the information. That's where you can go, and basically with this, you're able to call that particular key. So result JSON, like we had before. And just like if we're using a dictionary, basically think about a named key array in other languages, we can basically just call by that key. So in result JSON, I want to print out just whatever the value of IP is. And if I do that, you will see you just get the IP. So this is what you get when you do text. This is what you get when you print out everything you get from that JSON response. And this is what you get when you just simply call the value of IP. You get the IP address. So that's basically how this works. So, oops, where's my thing? There we go. And so that's where, again, when you're taking a look at it, again, as you start doing more programming, again, whether or not the request works, being able to do something off of the status code that comes in, again, headers that may or may not matter to you. Text will give you all the information simply as text. JSON pulls it in as a data type of JSON, so you can actually pull out the particular information. If we go here, let's see, ipfi.org. Again, I was kind of showing you that before. Open link. And here, they actually show you what the API usage is. So this is one of the big things. And again, whenever I talk about any of this kind of stuff, don't think like I'm being snarky to you. I'm only being snarky to you because I was a jackass when I was young. Again, I did not write notes properly. I tried to reinvent wheels. It was dumb. Anyways, same thing is true with these APIs. Like one of the big problems you get to with a lot of people that get in the technology world is one, they want to reinvent the wheel, and then two, they think they can just like magically figure out how things are done. And the big thing in the tech world is there's just configurations. Here's the reality. If you configure things properly, they work. If you don't, they don't. And the issue is the people that design those configuration systems probably were not very good at designing configuration systems. And so what you need to do is you need to go take a look at the documentation, and then it will literally tell you how you format whatever it is that you're doing, right? So this is the API URL. HTTPS, if I just want text, and it gives me the sample. So if I want something that looks like this, then API ipfi.org, that's it. That's the call that I make. If, on the other hand, I want something that looks like this, again, a key value pair, that's JSON, then I do api.ipfi.org, question mark, format equals JSON, and that will give me that. If I care about these other things with callbacks and get IPs or whatever, you'll get this kind of information there. Again, if we go over to this, let's see, documentation. Again, we go to JSON here. So this will give you the geographic information about different web pages or different IP addresses. And so you'll see here, this is how they format that request. Right, ip-api.com, JSON, and then this is the IP address. So in the other one, if I want it formatted as JSON, I had to do question mark format equals JSON. Here, if I want to format as JSON, I do /JSON and then whatever it is. Right, that's just simply how these people designed it, right? And then you can come down here and you can add, the different things that you're interested in, and then this is where you can get really nasty, right? So HTTP, ip-api.com, JSON, what the query is, question mark, fields, I want the status, I want the message, I want the continent, I want the continent code, I want the country, I want the country code, I want the region, right? This is a way that you can customize the values that are coming back if you don't want a lot of additional values. But this literally simply comes down to whatever these people decided is how they want you to interact with their REST API. Let's see here. JSON, right? So when we start dealing with JSON, especially once it starts getting larger, it's going to get ugly really quickly. And so one of the things we need to do is we basically sometimes we need to make the JSON look pretty so that we can actually figure out how to pull the information out that we want. So basically, when we're dealing with these JSON responses that come back, essentially they're going to be like nested sets. So it'll essentially open as a list. So sometimes it'll open as a list, and then you'll have one essentially dictionary value, but in there might be another dictionary value, and there might be another dictionary value. So you might have to go, response, index 0, this to get whatever name we're looking for. And so one of the things you have to do sometimes is visualize what this JSON structure looks like. And that's where the dumps function comes in. Basically, what dumps does is it turns your JSON value into a string that's formatted to look pretty. This is important, this whole string thing. This will screw you up. So a lot of times when you're looking at examples, instead of simply printing out oh, sorry about that. Spectrum Internet Service. We may have to tweak the times for these videos because there is something with Spectrum that I'm finding for some reason every day, somewhere between 3 to 4 o'clock, my internet dies. Like damn near every day. I thought I fixed the problem. That was my problem that I fixed. Anyways, I guess I had not fixed the problem. So anyways. What it's talking about here is making your JSON look pretty. And so basically what the dumps function does is it turns your JSON value into a string and formats it so it looks pretty, so you can figure out where the value is. The important thing to understand here, though, is that it does turn it into a string. So in a lot of examples, what they'll do is they'll create a variable, assign the dumps value to the variable, and then have you work with that new variable. The problem is you can get confused because once you have that variable, you may think that's JSON because when you print it out, it looks like pretty JSON. So you go, oh, if I want to get something out of that value, I can use this new variable as JSON. It's like, no, that's string. This makes it pretty as a string. Oops. Oh, that one failed too. Hold on a second. Let me just get this back on the other internet. All right, well, we'll see how well this goes. So anyways, it's a string. I'll show you in a second. So let's say look at the JSON pretty. Where is my thing? Okay. Well, let's take a look at the JSON pretty. Okay, so if we take a look at this first, so this is using the restcountries.com, the REST API that I showed you before, and we're going to be getting information for Belgium. So we want specific information about Belgium, right? So from request import get, don't worry about that. Result equals get. We're going to make this REST API call. We're going to format it in JSON, and then we're going to print out all the results. Right? And so when I run this, what you're going to see is we get back this. This is what we're going to get back, right? And this actually isn't so bad. So if we're trying to parse this, we're actually trying to read, right? I don't know if you can even see this. We open up with a square bracket. So a square bracket is equivalent of a list. So we know the first thing in the square bracket is going to be at index 0. Okay, so index 0. And then we open up a squiggly bracket, which is kind of like a dictionary. So, okay, so then we do, what the name is. So then we do name, and then we have another squiggly bracket. So then we do common, and then we get to Belgium. So if we simply wanted to print out the common name, or let's say the official name for Belgium, we would have to do whatever it is. We'd have to do result 0 name official, and that would give us Kingdom of Belgium. That's not too bad because that's all in the first line. But you know, what if I wanted, I don't know, God knows, something down here? What if I wanted the squiggly line version of the official name? All right, trying to figure that out can really suck. So that's where we use the dumps. So JSON is part of the default modules that are already installed in Python. So you can just call this. You do not have to install it. So we're going to do from JSON import dumps. And then what we're going to do here is we're going to print, we're going to use the dumps function, the value of result, and then for each thing, we're going to go into. So basically for each key value pair, whatever, we're going to indent in by 2, and this will give us something that's a little prettier, a little easier to look at. All right, so now, if I do this, if I print this out, now instead of getting just that mass of words, now I get this. And so it's a little bit easier to see using dumps. So we open up with a square bracket, so we know that's opened up as a list, so we know 0. And then we can come down and we can figure out what it is that we care about, right? So, you know, again, like we can come here and we can say, I don't know, if I want the capital, right? So let's say I want the capital is Brussels. So I can say, okay, I want it at 0. And then we open the squiggly bracket here. And so that's the next. And so I can kind of scroll down here. I can see capital. Okay, so I would go 0, capital, and that will give me Brussels. And yeah, just to be clear, there's a lot of trial and error. Again, one of the reasons you want standardization that doesn't change is so you can sit here for a day figuring out how to pull out the exact information that you want and then set it and forget it. Right? So basically, again, that's the dumps. So that's turning it into simply a string that is formatted, indenting by 2 for each layer basically in there. So we can go in there and try to figure out exactly what we're looking for. So if we want to try to pull out, you know, a specific value, like here, so I go here, so Belgium, I want to know what the official name of Belgium is. And so I'm going to print out result at index 0, at index name, at the official name. And if I want that, it will then give me Kingdom of Belgium. And that's how I can pull out that specific value out of that mess that comes back to you, right? And again, so with these other ones, okay, let's see this. What the, no. What did I do? You're right, one of those days. Go away. No, I don't. Close. Close. Oh, yeah. Okay. So then let's say I want the capital. So I want the official name and I want the capital. So I can pull this up, right? So I do Kingdom of Belgium is the official name. And then I go for the capital. And then what you see here is when I pull up the capital, it's pulling up that entire set. So this set is a list. So square bracket, Brussels, and then no additional commas. So this is a list with a single item. But that's ugly, right? Fuck. I've got this, but I don't want to have to, you know, do methods to turn that into something. But since I see that's a square, this square bracket, what I know is I know this is a list. So basically what I can do, what am I doing? What is going on? Oh, not sure what's going on here. Let me just do that so I don't screw something up. So what I can do here is result 0 capital. That gives me the name of the list. So I do result 0 capital 0. that will then give me just the name of the capital. And so that's one of the things, again, when you start dealing with JSON, you start dealing with these REST APIs, like don't expect just to be able to sit there and type all this crap out and have it work perfectly the first time. You're going to have to do a lot of troubleshooting here, where you put in one index, you put in the index you think it is, and then that doesn't work. You put another index, and you keep doing it until you can refine it down to what you want in order to get, again, something like the capital right there. So here, what do we have? Again, and this is how ugly this can get. So we have result at index 0, name, native name, in Deutsch, official. And if you want that, if you want the German name of Belgium, it's Koninklijk, it's that. It's squiggles. But again, you get all this information back, and that's the kind of thing to be thinking about when you're developing your application. Is like, what information do you actually need? And again, for you, for some reason, you might need the German. Again, especially if you're localizing a piece of software, like you have a web app and you're going to be localizing it. So one of the things is you say, we want people from 5 different languages to be pretty comfortable within our app. And so this is the kind of thing that you might need to be thinking about, is how do you pull out things like the names in people's specific languages. But that's basically how you pull out this information. And again, so think of it as lists and dictionaries and lists within dictionaries all nested together. So you get one, and then you get the next, and then you get the next, and then you figure it out. Let's see here. Oops. Okay, and then we get to the labs. So basically, the labs are a couple of things here. Wait a minute. Wait, I had one other thing. What was that? Oh yeah, I guess we can do this as an example too, just to make sure you guys understand how this works. So basically with this, it's very simple. I'm supposed to show you this first, and I showed you the other one. Oh well. So with this, we're going to go and we're going to get information about a particular IP address. So the IP address for CNN.com is 151.101.3.5. And so basically here, what we're going to do is we're going to try to find out specific information about that. And again, if we simply print the result, that's JSON. When we print that out, all right, we're going to get this. And again, this isn't too bad, right? We just saw that countries thing was a disaster. This isn't too bad, right? Status is success, country is United States, region is California, city is San Francisco, the whole 9 yards. Pretty easy. If we just want to pull out the city, right? Basically, we can do result, the value for the key city, and then we can just simply run this, and it will show San Francisco. Again, though, with this, when you're taking a look at it, even with the JSON this simple, it might be useful for you to dump it out just to make sure you're looking at all the information. So with this, again, it's going to turn that result into a string with a 2 indent. And so if we run that, now we get this the value back, basically, again, in this formatted way. So even as something as simple as getting this geographic information about this particular IP address, it's a lot easier to take a look at this to figure out what information that I care about. Again, latitude, longitude, the zip code, the city. It's like, okay, the key name is region name for California, right? Do I want the region, which is CA, or do I want the region name, which is California? The ISP of Fastly, or the org, or whatever else. So again, this is what dumps allows you to do. And again, what I just showed you before with the REST countries is where this just gets to be a lot more complicated. But yeah, so basically, if you've gotten used to the dictionaries and lists up until this point, again, you're going to get this back. And then you, in order to get the value for the key, this is what you do here. Okay, so with that, we then have the labs. So we restrict language and geography. Okay.
Question for you.
How are people unmuting themselves? But yes, how can I help you? What's up?
Oh, sorry.
No.
The indent feature, is there any kind of like rhyme or reason like why you choose two or one or how large of a list? Is there like a strategy you use to kind of understand or digest larger JSON files?
No, it's basically just up to you. So you can do indent one. I mean, here it doesn't really matter. It's just one. So yeah, with this, basically all this is generally going to be used for is for your understanding. So depending on how ugly this JSON response is, you may want to tweak that a little bit. Maybe lines are getting to be too long, that type of thing. Or there might be so many levels. Like so like two is fine. I like two. But let's say you start really going down quite a few levels. Maybe using two just gets you too far over to the side, and so you decide one is good enough. It's just a personal decision.
Thank you.
Yeah. Okay. So restrict. So this is again how we can start using these APIs to be useful for the applications that we're creating. So again, as I teach you folks this stuff, one of the big problems that I run into is how do I teach you things in the proper order? Right? There's just a whole bunch of stuff you'll have to learn, and, right? So anyways, basically with this, imagine if you were using a web app framework. So we talk about web app framework. One of the cool things with Python is you can build a lot of different things. So with Bottle or with Django or with Flask or with a number of others, these are actually frameworks that allow you to create full-fledged web applications. So you build the entire web application more or less in Python, and then have it do whatever it is that you want to do. So one of the things that's cool there is that you can actually write this kind of Python script into the code that you're writing, for your web application. And one of the things that you might want to do is restrict where people are coming from that are able to get to your site. So Pornhub right now, right? Apparently, they're no longer in Texas, and they're no longer in like 5 or 6 other states. There's this whole stuff with digital identity, whatever. Anyways, so Pornhub has decided it is cheaper to get the hell out of those states than try to deal with their laws. Well, one of the interesting things to be thinking about is on the internet, right? If you have a server that's internet accessible, then how do you prevent anyone from getting to that particular server? Again, think about things like Netflix or Disney Plus or anything like that, or sites like that, where they pay licensing fees for intellectual property based off of where people are watching the content at. So every person in the United States who views the latest whatever movie, Disney may have to pay 10 cents for each one of those views, but every Indian in India who watches the same movie, they only have to pay half a cent. Because the reality is, people are worth different amounts of money. It's not my fault, it's true. Right? But one of the things you have to be thinking about with that is like, how do you create a system to determine that? Whether somebody can get into the site or can't get into the site, how much things are going to be charged for, or whatever else. And so that's where we can use that IP -api.com. Their API. And basically, what we can do here is we can say if country equals the United States, I'm American, it's just how it is. Welcome in. We love people from the United States. Else, Brent, go away. We don't like stinky, people. right? So this is how, if somebody is coming to your site, you can do this request, you can get the country or whatever geographic information that you care about, and then basically make a dynamic decision based off of that. So again, I'm still using, let's see, I'm using TunnelBear right now. And so with TunnelBear, it has me in the United States currently. So if I simply run this as it is, welcome in, we love people from the United States. Now again, to show you that this is completely dynamic, I'm now gonna go over, ooh, which European do I get to piss off today? This is my happy day. I get to piss off a European, it's okay. It's good fun, I swear. Let's see, Portuguese. Portuguese seem like they have a sense of humor. So I'm connecting to a server in Portugal. Hopefully, you know. Okay, so now I'm connected to that server in Portugal. And so when I run the exact same script, go away, we don't like stinky Portugal people. Right? Again, this is just a basic thing for a web app that might be important for you. So with this, again, from requests, import get, so the get function, response equals get. We go to this, IP-api.com, JSON. We're going to bring it in, use the JSON method, so it actually comes in as JSON. For troubleshooting purposes, if you're having problems, I just have this commented out. You can print out the entire JSON response if you're running into issues. Country equals response country, right? So again, when you get the response, the key that you're going to care about is country. That's what we're testing for here. Again, if you just want to put in a manual country for whatever reason, you can do that. If you don't have a fancy VPN, you can just plug in a manual country. So if country equals, so equal, not equal, equal tries to set the value. Equal means that is one side equal to the other. If country equals United States, print F string, welcome in, we love people from, again, that variable value for country. Else, print, go away, we don't like stinky, variable value for country, people. And again, if you're dealing with Bottle or one of the web app frameworks, instead of printing out on the screen, you could literally redirect people to a different page. So again, if somebody is coming from a French-speaking country, you could redirect them to the French side of your website. If they're coming from an English-speaking country, you could redirect them automatically to the English-speaking part of your website, Spanish, the whole 9 yards. So anyways, this is this particular lab that you can play with. Again, all you're going to have to do is import or install requests, Python 3 space -m, pip install requests. That's the only thing you're going to do here. You don't need any API keys or anything else. Then we're going to go to the lab language. So this is an interesting one. So basically what this is going to do is I'll just run this for you first, is we're going to find out what countries speak a particular language. And so again, this could be useful for if you're localizing your web application for many different languages, somebody is coming in, so you can take the country that they're coming in from and try to figure out what language, right? So anyways, what language do I care about? Let's see, English. I want countries that speak English. It asks me here, and this will give me all the countries that speak English, which is a whole bunch. What language? So it's going to ask me the what language down here, and I can say Spanish. And this is going to give me all the countries. I will say Puerto Rico is not a country, but anyways, it'll give us all the countries that speak Spanish. If I say, let's say Thai, it'll give me the one country that speaks Thai. Right? So basically, this is what this particular script does. So with this, we do from requests, import get, and from JSON, import dumps. So we're only going to be doing this for troubleshooting purposes if you need to troubleshoot. We're going to do a while true loop. So again, I like these to be dynamic so you can keep tippy-tap typing. So while true, this is going to keep looping. It'll keep looping until you hit Control-C. Control-C will kill it, or if you hit the trash can, it'll kill it. Language, So language is a variable name equals input what language. So this is where you type in what language you're interested in. That's a variable name. Response equals get f string from restcountries.com v3.1 lang, and the language, that's what we're going to plug in. So English, Spanish, Russian, whatever else. Response JSON equals response.json. So basically here, I'm getting this response in, but I'm not using the JSON. I am just pulling it in and then turning the JSON on down here. The reason that I'm doing that is basically if I need to do some troubleshooting, right? So basically I have this dumps here. And so with the dumps, I can dump response indent2 to see what it looks like. The other thing that I have here is for troubleshooting purposes. So if I do this with a response, it might actually be too long. Like I'm trying to figure something out. So if I run this, what language? English. It failed. Oh, anyways. Why did that fail? Hold on. Did I type that right? English. Oh, I'm an idiot. .txt. Oh, never mind. I will have you know, these are all beta classes. These are all beta classes. Okay. So anyways, so the issue here is I was stupid. So yeah, in order to do dumps, you actually have to dump the JSON into dumps to get the string. So anyways, so print dumps response JSON indent2. Anywho, with this, one of the issues you might get into is that the JSON is too long for the terminal session. So basically, you might be trying to figure out, like, again, you just got all this kind of stuff, and it keeps scrolling. I will scroll to the point where I just get to this SRP, and then this, right? So basically, there were so many responses, they can't all fit in this terminal session. And so if that's the case, one of the things that you can do, oops, is you can actually write this to a text file, right? So again, make sure to do the underscore JSON. You want this value here. Anyways, so with open, we're going to output to out.txt, W for overwrite as file. File.write dumps response underscore JSON indent2. So this is going to basically output everything that comes back from this JSON response into a text file so that it's easier to deal with. Again, if we don't do anything else with the working directory, this will default output to my user's home root directory. So if I do this, and I say English again, we get all that. And then what I can do is I can come to here, I go to Eli, so that's me, I go to out.txt, and basically this is the entire JSON output. Right, and so this is, again, this is one of those things with computer programming. A lot of people think like all you're ever going to be doing is tippy-tap typing all day. A lot of times, one of the things your job is going to be is literally going through all of this mess and trying to figure out what it is that you actually care about. All right, in Polish, the common name is Eritrea. In Portuguese, the common name is Eritrea. Anyways, So basically, this is a way to output all of that, and then you get to have the fun of just going through here, all the key value pairs. See, so name, country of Cura, official country of Cura, NLD, land of Cura, PAP, PACE, right? All this kind of stuff. So that's one of the things that you can do from a troubleshooting routine. If you're trying to print this out onto the screen and for whatever reason, it's just too long, you can print it out, you can output it to a text file. Then we come down here for the status. So now, since people are tippy-tap typing things in, and they make mistakes, One of the things you have to realize is basically in Python, kind of as I've shown you, if you screw up, right, the code is just going to fail. The code just fails. You don't necessarily want that. So one of the things we're going to do here is we're going to take a look at the status code. So status is going to equal response.status code. So the response we get back, whatever the status code is. So basically, if we put in a language that is known, we'll get a 200 status code. So if status equals 200, for each country that we get, for country in response JSON, we're going to print the country name common. So each country that comes back, we're going to print their common name. But here's the thing. What if we fat finger something, right? I'm an American. How do you spell Belgian? How do you spell Belgian? I don't know how to spell Belgian. Anyways, so like I don't necessarily want this code to fail if I misspell Belgian. I just want it to ask me something again. So if the status is anything other than 200, print language, whatever language you put in, not found, and whatever the status code is. Right? So I showed you English or whatever before. Belgian, right? That's how you spell Belgian. Anyways, so if I do that, I hit enter. Language Belgian and not found, and I see what the status code is 404. And again, I just put that there for troubleshooting to make sure I'm not losing my mind. So anyways, this is this particular lab. And again, it allows you just to pull that kind of information out. The final lab is geography. And this is for the common name and the capital for wherever you're in. All right, so again, I'm using VPN. I'm traveling all over the world using VPN services. So right now I'm in Portugal. So basically what I can do, just to give you an example, so I can run this. And when I run this, so this is just this is simply getting information. It's pulling my public IP address. Based off of that public IP address, it's then figuring out basically where I am. And so the official name for where I am is Portugal, and the capital is Lisbon, right? If I change, so if I go here and, I don't know, Belgium, come on, go to Belgium. Dun, dun, dun. Come on, Belgium. Okay, there we go. Now we're now connected to Belgium. So basically I rerun this, now being connected to Belgium, and it says Belgium is the official name and Brussels is the capital, right? So it's doing all of this dynamically. So if we take a look at this, again, from request, get, import get, we're doing the JSON import dumps just for troubleshooting purposes. Response equals get, basically this is the IP address information, ip-api.com, JSON, return it as a JSON value. Country equals response, the country that I'm in. And then with this, we're nesting, right? We're layering different REST APIs. So we go to one REST API, from the information from that REST API, we go to the next REST API. We can stack these quite a big ways. So response underscore geo, so basically the geographic response, get, REST countries. This is an F string here, so then I can put that variable value that I created, right? So I get response country is now set to the variable value for country. I then go to REST countries, plug in that variable value, and it says full text equals true.json. So this is word wrap. when you see this, just to make sure you know it's word wrap. It's all actually on one line. It just wraps. Some people get confused with that. That's why I bring that up. So anyways, so basically, I'm plugging that in. And then for record and response, geo, print record name, common, print record capital 0, like we did before. And so this will print the name, the common name, and it will print the capital. I do this loop because one of the things with this is, like, if you're in the United States, again, and this is the kind of thing why you got to play. You have to frickin' play with your code because you will get weird damn issues. And so when I'm in the United States, when you use the REST countries API, it's a very, God bless it, it is what it is. But if you say United States, not only will it find United States, but it will find everything else with United States in it. And so that's why I have the for record and response. So you might actually get multiple records. How you deal with that, that's extra credit for you. So since I'm now in the United States, what you'll see is United States, minor outlying islands, capitals Washington, D.C. United States, Washington, D.C. United States, Virgin Islands, Charlotte, Amelie. Right. So anyways, that's why you got to play with some of this stuff to figure out. So again, when you do the request with REST countries, basically it's just if that fits into anything, you'll get all the results back. And so that's why you do that there. And so those are the labs. If you want to play around with them, I have something to do tonight. So it's 3:46. So I will stick around for about half an hour if people are interested. If you're not, you can drop off. You don't have to stick around. No grades here. But if you do want to actually type these out, and if you run into problems, be able to ask questions, I'm more than happy to stick around for about half an hour. End of the class, end of the seminar part. Is there any questions there? Anybody have any questions?
I got one.
Yep.
So when we do Android development, when we get the response back, we usually convert them into like data classes. So if I'm doing this over and over again, and I don't want to do this like indexing into the JSON over and over again, is there like a easy way that Python allows me to like convert into some type of Python object so that I can just do like like record dot name dot common instead of just indexing into it like this?
Oh, where you do. I've played with that a little bit. I think you might be able to. Yeah, that's a great question. I'm not sure I can answer that one though. So I know when I've dealt with the OpenAI responses, that's what it looks like. You actually do that response dot blah dot blah whatever. Whenever I've dealt with the normal REST APIs, we've always done it this way. So that is something I will do some homework on. I'm not quite sure what the answer to this though, honestly. Any other questions?
So I did ask this question in the chat earlier, but people talk about APIs and they talk about RESTful APIs. I mean, in your definition, is there like is it a protocol specific why it's called a REST specific API, or is there a direct delineation of why it's named that?
Oh, yeah, if you do a Google search, you can come up with it. And yeah, there's this whole, yeah, it's was it the whatever the hell my own thing was, RESTful state, what did I call it? Representational state transfer. So again, one of the things you have to think about in the technology world, again, as I will say, I'm an admin guy, I'm a systems guy. In the tech world, lots of people do lots of different things. So once when you're at the computer science level, basically how all of this stuff like really seriously works is incredibly important, and you can sit around and drink beer and have great conversations over. The thing is, for people at my level, again, more like a systems type people, we just kind of get the finished product, and then we'll deal with the finished product. So as far as I am concerned, when I deal with REST APIs, a lot of how this stuff actually works under the hood doesn't really matter to me. Again, there's interesting stuff as far as you start talking about like signaling and how the communication goes from the requester, how the response gets sent back. A lot of that is in there. And so that's when you deal with different APIs. So like you can install like software development kits, like with OpenAI. When you deal with their API, generally, you're going to install an OpenAI module into Python, into your Python environment, and then you're going to interact with that module in order to do the API call. And so with that, they can basically design everything from the transport encryption, so encryption between the two devices, to how the communication is going to work and the whole 9 yards. And so basically, when you're dealing with these REST APIs, the idea with this is these are open web-facing APIs that the end user isn't going to have to muck around a lot in order to be able to use. Now, so you can use curl. So now, like with PHP and things, you can actually use curl in order to interact with REST APIs. And so as long as you're able to get to the URL and be able to get the response back, any program that you have that's able to do that will be able to work, and you don't necessarily have to install additional modules or anything like that. I don't know. Does that make sense?
Yep, that answers my question. I appreciate it. I just wanted to hear what you thought personally. Like, how do you think about the idea, like what's the REST API to yourself? Okay.
Yeah.
Yeah.
Yeah. Basically, when I think about the REST API, again, I never dealt with SOAP. So I had friends talk about SOAP back in 2005, so I just never dealt with it, honestly. The way that I think about the REST API is just something that essentially I can make a call to a URL, and then I'm able to pull back generally values in JSON. That's generally what I consider REST. Again, whether the computer science people would agree with that, that's on them.
Are there benefits of using JSON versus XML that you've experienced yourself? I know XML is another format you can sometimes request from APIs. Do you have any, I guess, input on that or
Yeah, I don't know.
experience?
XML, I mean, XML was the hot thing up until like 2010, 2011, and then it's just kind of fallen on the wayside. So at least with Python and the things that I've used, I like using JSON is easier to parse just because you got those key value pairs. It's a lot easier to deal with. Um, yeah, XML. It's kind of sad what happened to XML. XML should be further than it is. Yeah, I don't know. I've dealt with XML like with some of the like when I deal with like network scanning, again, like admin type software, a lot of times it'll output it in XML. And so what's nice with XML, basically when we talk about XML, right? Is again, it's tags, but it's extensible markup language. The idea, so with HTML, the markup language is essentially hard coded. H1 is H1, H2 is H2, P is P, whatever else. XML, the idea is, hey, what if we had a markup language and you kind of customize it, right? So, like with JSON, we do squiggly. Let's say if I get an IP address, right? I get IP, and that's the key. And then, 192.168.1.1, and that's the value pair. And that's what JSON would look like. And again, just make it a lot more complicated. If you're dealing with XML, you use tags instead. And so tag, you might have the script pop out, and it would just simply say IP, and then 192.168.1.1, and then you close the tag IP, right? So that would be more or less what XML would look like. And then again, with this, you know, you might have, let's say, that, and then like as you go down the layers, so you might have like OS, and then say like Mac OS, and then like here you might have like, I don't know, updates, and then that would give you the number of whatever updates you're up to, and that's kind of what XML would end up looking like. So yeah, no, I mean, you just, unless I'm using, like say Linux tools or whatever, and they output to XML for some reason, I just don't see a lot of XML anymore, at least for what I'm playing around with.
Thank you.
Let's see, up in the comment section. The language code needs double quotes inside single quotes where you print the country name, otherwise it throws an error. Which one is that? Yeah, do remember Python, double quotes, single quotes. Wait a minute. The language code. Which is my language code? Language code. What was I doing? F. Oh, fuck. That's weird. Okay, yeah. Beta classes. So this F string down here. Huh. Maybe because it's in that. So normally what's supposed to happen when you're using Python, almost any programming language, you open something, you close something. So you have to be very careful, right, with quotation marks especially, because if you open with a single quotation mark, as soon as you get another single quotation mark, it should close. And so that's where, yes, technically, see how we have here, F, single quotation mark, right? What he's talking about is these should be double. So single quotation mark open, single quotation mark close, double quotation mark open, double quotation mark close, double close. And but it did work. But it did work. So that's the right way to do it. I don't know why it worked. Yeah, so just be careful whenever, especially when you're doing the print statements, you're doing the quotation marks. Again, open, close. Maybe it's smart enough now to figure out it's inside a nested bracket. Mine did not, lol. Yeah, it's a Windows people. It's a Windows people. Yeah, no, it's not smart. To be clear, AI doesn't exist. None of this is smart. None of it is smart. You do have, again, one of the problems you get to, I've talked about that with stacks, right? And so a lot of times when people hear like the concept of stacked, they just think it's a word. They're like, yeah, man, I got a stack. It's like, no, these words actually matter. These words actually matter. So when we talk about the stack, right, it's the whole stack of technology you're using in order to build whatever it is that you are, right? So you got your hardware. I normally don't think about that anymore. But on top of that, you then have your OS. And then on top of that, like with this, you have your interpreters. And then on top of that, you may have other stuff, whatever. One of the interesting things that you run into is different OSs deal with things like text slightly differently. Again, Windows is generally doesn't care about capitalization. Linux, Mac generally do care about capitalization. There's all kinds of weird screwy crap in there. And then not only that, is the interpreter might be slightly different per OS. And so there's the ways that you're supposed to do things. So the idea is if you do it the way you're supposed to do it, then it should work on whatever stack you have. As long as you do it correctly, it'll work. The quirk in the real world is sometimes code will work on one stack when you do it improperly, and then it'll fail on anybody else's. And so that's where you'll hear in the tech world, what will make everybody groan is when coders or people say, well, it works on my computer, right? So if I run something and it works on my computer and then it's not working on your computer, well, it works on my computer. One of the problems you can run into is maybe your computer essentially allows for things that are not supposed to occur. So yeah, and be careful of that. And none of this is smart. I want to be clear. ChatGPT is not AI. We are nowhere freaking close to general AI. We're not even the ballpark of general AI. We're like, imagine Taylor Swift is having a concert in Brazil and I'm in a canoe in Alaska. And that's how close we are to AI. I just want to be clear about this. Again, all the functionality is cool. OpenAI is freaking awesome. Claude is awesome. Olama is awesome. None of them are AI. So anyways. Let's see here. Question, can you request photos in JSON? You can request photo locations. So that'll be important. Tuesday? I think it's Tuesday. Next Tuesday, we're doing a class on DALL-E. Well, we're doing a class on OpenAI. One of the things we're going to be doing is DALL-E. And so one of the interesting things with that is that it's going to give you a URL back. So you're going to make your call to DALL-E. So you're going to say, I want a picture of Elon Musk riding a hamster, right? It's going to create a picture of Elon Musk riding a hamster. And then what it's going to do is it's going to give you back a JSON response with a whole bunch of crappy information. One of the pieces of information there is a URL, right? And so what happens, and again, this is where you have to start thinking about architecture. Again, this is my frustration with kind of like the modern world, is the kids nowadays, they don't give a damn about architecture. They just don't care. But you really, I swear to you, like you got to think about this, right? So anyways, so you get the JSON response back from OpenAI, and it's going to give you a URL, because what happens, right, is with JSON, JSON is just text. JSON is just text. That's part of one of the standards. You're just sending text. All right, so what's going to happen is you have your little computer, you make a request to OpenAI, right, to the DALL-E server. The DALL-E server is going to process that. It is then going to take the picture and it's going to save it into its data store. So they use Azure because they have a partnership with Microsoft. So they have some kind of storage bucket, some insane storage bucket up in Azure. And so it's going to create the image. It's then going to save the image to Azure. What it will then send back to you is it will send back a JSON response with a whole bunch of information. One of the pieces of information is a URL to this image. And so one of the things, again, from this architecture standpoint, you have to realize is OpenAI, more or less, only saves this image for 1 hour. So you have to be really careful. Like if you wanted to create like an AI image platform, and they give you back the URL, and then all you do is you just embed the URL, right? You take the URL, you dump it in your database, and then you dynamically build galleries with these URLs. What you have to realize is after an hour, that image is going to get deleted. So then you're going to have a whole bunch of embeds that are going to go nowhere. So what you have to do is you have to grab the URL. So your server then has to grab the URL. It then has to basically do a wget or whatever you're going to do in order to then pull that image into your data store it in your data store, and then you're going to embed from your data store. So that's basically how things like DALL-E or any image, they will send you a they'll send you essentially a link to that image that will then allow you to either access it or download it. Ever used Postman? It's an API browsing tool. No, never used Postman. No, Postman API. Top API tool. Where 30 million developers use Postman, get started by signing up or downloading the desktop app. Postman is an API platform for building and using APIs. Postman simplifies each step of the API lifecycle and streamlines collaboration so you can create better APIs faster. Nope, never used Postman. Even CrowdStrike has an API. Yeah, almost everything has an API. Because that's the thing is like, so if you go back to the old days of 2000, which are shockingly old at this point, everything was proprietary. I mean, like, fuck you, proprietary back then, right? And that was the thing. So like, if you were in the Microsoft stack, I mean, you were super glued to the Microsoft stack, right? So that's why Active Directory was so important. There's something called Active Directory. It was the security software. It's like a authentication platform, LDAP, whatever. Anyways, and so the thing was, so you could log into your computer. When you logged into your computer was part of a domain. So you had a client computer, a server computer, could be set up as what was called a domain controller. Way back in the day, there were PDCs and BDCs, and they just went to DCs. Anyways, that domain controller, you could then sit down and create security group policies. There are security policies and group policies, all kinds of policies. But anyways, you could sit down and you could write out just an insane number of policies. What users did you want to allow to use the USB port? Again, one of the things that makes me very frustrated about modern security is I want to be crystal clear. We actually had decent security systems about 20 damn years ago. The reason we're getting hacked to high hell and back isn't because of, I mean, it is crappy software, but it's not actually because of crappy software. It's because of garbage administrators. Anyways, so all the way back then, right? You could literally say, you don't like, so you could put people into groups. So you had user accounts and groups, there's organizational units. Anyways, you could put people into groups. And you could say, I don't want this level of employee to be able to have access to the USB ports, right? So you plug a USB port in, at least as far as the operating system was concerned. They just want to get access to the USB port, right? I don't want them to do all of this kind of different stuff. Well, the thing was, right, so not only could I do that for the computer, right? So you have a Windows XP computer with a 2003 server. So not only could I do that with a Windows XP server, but if I wanted to do that with printers. So certain users could gain access to the color printer, and certain users could gain access to the black and white printers, right? That was print services. And then there was a VPN services, routing and remote access service. That was built into the Windows server. And then on top of that, again, you had Exchange server. So Exchange server was the email server. And so you had Outlook. Outlook was the client for Exchange server. And so when you logged in, your Outlook client automatically had all the credentials for being able to do all the email services that you wanted to do. And then you ended up having a Link server was a communication server. You had a SharePoint server. You had all these kinds of different servers. So anyways, you go into the Microsoft world. The Microsoft stack was just ridiculous, right? You go in there, everything from database servers to email servers to Active Directory servers, and it was all tightly controlled, right? And they would teach you about the security, but it didn't really matter, right? Again, when I got my MCSE, like Cerebros, what the hell it was called. Basically, I learned what the name was and had some bit encryption, and that was it. Right? You didn't get to muck with it. It was like, this is what the operating system has, right? So anyways, as we go into the 2010 timeframe, basically what happens is with service-oriented architecture, that also comes into the localized world, right? The local world. And so more people want to be able to do more programming things, again, be able to access and deal with systems in new and innovative ways. And so that's when you actually started seeing more and more APIs for crap that used to never talk to anybody else, right? Again, like Cisco, right? So when software-defined networking came out, Cisco 1, is it? Don't quote me on that, but Cisco came out with an API, and not for their web services. They actually have an API for their hardware. So if you want to programmatically change how your network infrastructure is functioning, you could actually have a script communicate to the Cisco equipment using, I think it was called the Cisco 1 API, and be able to modify things. That's where so there's something called software-defined networking that, oh, I don't know. I don't know what happened to software-defined networking. It was kind of cool. The idea was that your network would dynamically change configurations based off of the situation. Basically, you could have triggers, and the events that would fire off were literally how the network would function properly. So the way I used to explain it, let's say you're having a shooting, a workplace violence event, or let's say you're having a school shooting event, right? So somebody walks into the school with an AR-15. Well, here's the thing. Somebody walks into your school with your AR-15, you don't need to be sending emails. You just don't, right? You don't need to be watching Hulu. You don't need to be doing well, you might need to do a VoIP call. Anyways, right? So one of the things is especially with networking equipment, again, not that long ago, there's only so much network bandwidth, right? Especially when you start doing high definition video, right? You start pumping high definition video, 4K video, at least a couple of years ago, it would take 25 megabits per second per stream, per stream. So imagine this. Imagine if every classroom in a school had a 4K TV. And so somebody walks in with an AR-15, and nobody needs to be doing damn FTP. The online backup, that doesn't need to happen. All the normal networking services do not need to occur. So what if I could smack a button, right? So I have my little Raspberry Pi or Arduino, and on that Raspberry Pi or Arduino was a big ass button. And basically, when that button gets pressed, my little IoT device sends a command to either a server or whatever else to say emergency is occurring. And basically, that could then, to the Cisco API, essentially take the priority of everything other than RTMP to fucking 0, and then basically give RTMP, that's the video protocol, basically all the priority. So now, as people are trying to figure out what to do in the school, every single classroom in the school is now getting a 4K video stream following what the shooter is doing so that they can make their decision, right? And that's the kind of cool stuff you start talking about with these APIs. And again, once APIs start getting out of just the web world, is again that idea of your infrastructure needs to be able to adapt dynamically based off of whatever your requirements are, right? And so that was one of the cool things, like I said, with Cisco APIs and all that kind of stuff. And so, yeah, there's a lot of APIs out there. So any of the hardware you're dealing with, any of the software, it is a good idea to see if they have APIs. And again, if you're looking at vendors, right, 50 or $100 more per device for a piece of hardware that has an API you can use might be well worth it. Or it might be a waste of money. Anyways, yeah. Oh, wow. It is 4:15. I think that is the 30-minute mark. I actually do have something to go to tonight. Any questions? Happy to answer any more questions. Anybody else have any more questions? No? Cool. Yep. Okay. So Friday, we're doing the the OS module. So basically, with the OS module, you can use your Python script to communicate with the underlying OS. That should be fun with Windows, folks. We'll see how that works. Tuesday, we're going to be doing the OpenAI module, and then next Thursday, we're either going to be doing web scraping or Olama. So just I don't know, just make sure to sign up on Meetup or whatever, so you know about these classes. And I think that's all I do. Where can I find the recording? So the recording, once it's up, probably up tomorrow, is on the Eli the Computer Guy channel. Oh, let's see here. So Eli the Computer Guy. No, don't give me my site. I don't want my site. I want YouTube. Ah, Eli the Computer Guy YouTube. So if you go to Eli the Computer Guy YouTube, you can come to my dead channel. There is nothing quite so like having over 1 million subscribers and getting 2,000 views. Anyways, but you can come here, and as you can see, so for the Zoom, they record, and so basically once it's done, I have to download it, I throw it through Final Cut, I chop some crap off, and then I upload it here. So it's Eli, the Computer Guy channel on YouTube, and it should be up sometime tomorrow. And yeah, it's just there. So can I drop a link? I don't know, it's there. Drop the link. So cool. Okay, got a thumb up, and that's it. Cool deal. Okay, so with that, I will see you on Friday or in the next class. See you later.